In this video, we will talk about how to find the probability of the union of two sets. So I want to begin with an example, which says that a card is randomly selected from a standard deck of 52 cards. What is the probability that the card is, part A asks, a red card? So in a deck of 52 cards, the red cards are the hearts and the diamonds, so those two suits, whereas there are some black cards, and the black cards are the spades and the clubs. So we are trying to compute the probability of a red card. So I'm just going to probability of red. So using our formula for probability with equally likely outcomes, I'll have a fraction. And on the top, I put the number of successful outcomes. And in this case, I have a success if the card is red. So I'll put the number of reds on top. And on the bottom, I have to put the number of elements in the sample space, or the total number of outcomes. So that's going to be the total number of cards. So for the red cards, well, I count up all the hearts and diamonds. There's 13 hearts and 13 diamonds. There's 52 total cards, so I put that on the bottom. So we get 26 divided by 52, which simplifies to 1/2. And that's our probability. So we're starting off with a shorter one. Let's move on to part B, which asks, what's the probability now that our card is 3 or 7? All right, so we want to find the probability of getting a 3 or a 7. So using my formula for probability, I put the number of successful outcomes on the top. And in this case, I have a success if I get either a 3 or a 7. So I need to count the number of 3s or 7s, the number of cards that are either a 3 or a 7. And on the bottom, again, I put the total number of outcomes. In this case, it's the total, the outcomes are the different cards I could get. So total number of cards. So I know the denominator is 52. There's 52 total cards. We had written that down before as well in part A. And on the top, if I want to count the number of 3s or 7s, conceptually, I just got to count the number of 3s and then add that to the number of 7s. All right, and in our deck of cards, there's 4 3s and there's 4 7s. So all over 52. So this becomes 8 over 52. And I could simplify this fraction a little bit. I noticed that I could divide 8 and 52 both by 4. And if I divide them both by 4, we end up with 2 on the top and 13 on the bottom. And that is our probability. So one thing that I want to point out more generally about part B here is, when I see the word or, that makes us think of a union. We're actually counting the number of elements in a union of two sets on the numerator here. So I want to recall something about the number of elements in a union of sets. Let me zoom out a little bit so we can see this computation. Okay, so the number of elements in A union B in general is the number of elements in A plus the number of elements in B minus the number of elements in the intersection of A and B. So in general, that's the case. But if my two sets A and B are disjoint, that would look like I have a circle for A, I have a circle for B in my Venn diagram in my universal set. And in a picture like this, how many things are in the intersection? The number of elements in the intersection would be, well, there is no intersection here. The circles don't overlap. So there's no elements in the intersection. So my formula simplifies to just, n of A plus n of B. And that's what we ended up doing, just kind of conceptually, in this computation above. I was finding the number of 3s or 7s, that was a union, but they were disjoint sets. The cards that are 3s and the cards that are 7s, they're disjoint. There's nothing that they have in common. And that's why to count it, I just added those two up. All right, so let's look at one more part to this example. Part C. So what's the probability that this card is a 3 or a red card? So I want to find the probability that we get a 3 or a red. So if I do the same type of thing, I'm going to count the number of elements in this set on the top. So that's the number of successful outcomes. So this is the number of 3s or reds on the top. And on the bottom, the total number of outcomes, which in this case, it's the total number of cards, because my outcome is just drawing a card. Alrighty, so let's work out what this is. So just like in part B, seeing the word or makes us think of the symbol union, except this time the set of 3s and the set of reds, they are not disjoint. They do have an overlap. A card can be a 3 and also a red. So we're going to have to use the more general formula to count the number of elements in this union. Okay, so let's write down that general formula. For the numerator of this fraction, so our probability is going to be equal to some fraction. And let's give myself some room here. And the numerator was the number of elements in a union. So we're going to have the number of elements in the first set A plus the number of elements in the second set B minus the number of elements in the intersection of the two sets. Okay, and in this case, the first set was the set of 3s. So we'll have the number of 3s. And the second set was the set of red cards. So we'll add the number of reds. And then minus the number of elements in the intersection, which means the number of cards that are both 3s and reds. So the number of, let me just say, red 3s, because those are the cards that are 3 and also red. And the bottom was the total number of outcomes, which in this case is the total number of cards, which was 52. And let's start to work out some of these things. The number of 3s we've already done. That's 4. Plus the number of reds, we've done that as well. That's 26. And then minus some missing number, and let's put the 52 on the bottom. And now let's work out, well, how many red 3s are there? Well, there's 2 red suits. There are the diamonds and there's the hearts. So we could either have the 3 of diamonds, or we could have the 3 of hearts. So there's 2 cards that are red 3s. So we're going to subtract 2. That's how many elements we have in this intersection. Alrighty, so 4 plus 26 minus 2 gives us 28, and then divided by 52. And we can divide both the top and the bottom by 4 to simplify this fraction. In doing that, we end up with 7 on the top and 13 on the bottom. And that is our probability. So in terms of our goals for this section, we've done an example to see how we can compute probabilities when our set is either a disjoint or a non-disjoint union.